Stephen has a computer science degree from Texas A&M, and he started his career at Shell at the West Hollow Technology Center in Houston. He was involved with the creation of data warehouse automation and master data management solutions while there, and ultimately became commercialized. And now part of Magnitude Software. Stephen now works for Snowflake, helping customers with their digital transformations using Snowflake's cloud data platform. And so today, he's going to be presenting to us on Snowflake's native support for WITSML.
Awesome, thanks for that intro. And thanks to everyone for joining us virtually today. As was just mentioned, I'm Stephen Pace, a solution architect for Snowflake, and I'm going to be introducing Snowflake for those of you that aren't familiar with it, and then also describing how we're helping companies move their workloads into the cloud, and perhaps more importantly in this environment, save money while doing it. And while we're at it, how we fit with PPDM and the standards that companies, particularly in the energy space, are using today. So I've got a few slides with an overview, and then we're going to go into a live demo, which includes me ingesting semi-structured data. In this case, WITSML format I downloaded from Energistics, so thank you, Jay, and querying it using regular SQL, and then hopefully I'll have some time for questions at the end. We're also around at the virtual booth over these 2 days, so you can also catch us over there if you end up having some questions. Let's get going. Gartner has suggested that 70% of all database workloads will be in the cloud by 2022. So that's not that far away. However, it's difficult to use yesterday's technology to solve today's data problems, much less tomorrow's. So the volumes have grown larger and the types of data are different. On-premises worked well for a time. We got the answers we wanted using regular SQL, but we were often constrained. We would run out of memory, we would run out of disk. Early cloud options essentially took what we had on premises and then picked them up and moved them to the cloud. But they essentially suffered from many of the same limitations. And so, for example, for Internet of Things and semi-structured data, traditional databases really weren't a great fit for that. Companies started looking for things like Hadoop, and it was cheap storage, it was all the data, but it was hard to manage and tended to be quite slow to query. And Steve Cooper said this in his keynote today when he said 70% of those projects really didn't return on some of their initial promises. So enter Snowflake. We're a brand new architecture taking the world by storm. Started in 2012, but we're really ramping up. And we can load all of your data, structured and semi-structured data, for $23 a compressed terabyte per month with unlimited storage and essentially unlimited compute, all using regular SQL that you and your staff probably already know and love. So with that, this is probably not an exact replica of your architecture, but most companies today have a complex web of technologies that are stitched together over time. They deliver, your original sources from SAP and all your upstream operational systems, all the way through to the people who need to consume that data. And across the integration and transformation, aggregation, there's a lot of different tools deployed, and it starts to become a governance problem. So, and you get silos of data. Do I query the data lake for this piece of data, or maybe I query the data warehouse or a data mart? And multiple copies of data emerge, for various parts of the business to meet their requirements. And in the end, you spend more time managing the infrastructure than you actually do working with the data itself. So Snowflake allows you to build a modern data architecture using our cloud data platform. It's a single platform. It enables secure, governed access to all data, supporting many different types of workloads. More importantly, it helps eliminate the complexity, cost, and constraints we saw on the previous slide. So, we're available in all three major infrastructure clouds: AWS, Azure, and Google. Supporting a wide range of workloads. Many of you, if you have heard of Snowflake, may have thought of us as a data warehouse, but we're also taking a lot of the data lake workloads, moving them into Snowflake, supporting also data engineering, data science. We've got companies building applications on top of Snowflake. And we've also got a very innovative data exchange, especially in energy companies, buy a lot of external data and get it from external sources. Could be from people like IHS, or some of the like conduit resources or Zima that aggregate the data, weather data, and we have ways of bringing that data into your warehouse, not copying the data, but actually having it appear in real time for when the providers that update their database, it's live in yours. So that's also a differentiator for us. So what's really different about us? I want to talk, if you just take nothing away from the slides, this is the most important one to understand how we're unique. So this is our architecture. So we are built natively on top of these infrastructure clouds, and we also help you support a multi-cloud strategy if you have one or you don't want to be beholden to one cloud provider. So you could do most of your things in AWS, but maybe you want to try out machine learning in Google. That's something that we support. Next is the storage layer, and all of your storage in Snowflake is using the cloud object store. So if it's AWS, it's S3. If it's Azure, it's blob storage, or it's GCS for Google. And that's how we can charge you so cheap, $23 a compressed terabyte per month with 11 nines of resilience. Your data is stored in 3 different data centers. You could be querying data and a meteor could come down and destroy one of those data centers, and your query would just keep on trucking, which is what you want. And we're managing for customers over 150 petabytes of data today, and it's growing every single week. So beyond that, the real brains of the operation we call global services. So global services encrypts your data as it gets stored. It gleans statistics about that data as we're writing it. So you don't need traditional database indexes. When we write the data, we say, what's the min and the max? Is it something null or not? So that we can prune down your queries to make them fast. So there's not even a concept of an index in our database. So we don't need them to give performance queries. And we could even replicate your data to other regions and other clouds for disaster recovery purposes if that's something you want. So last but not least is the compute layer. Now, we're a pay-as-you-go service, so if you're not using something, it's just off, which is why we're representing it as nothing there. But if you go and do a query, you basically can specify what kind of compute you want to throw at a given process. And so we charge you by the second, and we turn it off when you're not using it. And unlike some systems, these virtual warehouses can see all of your data. So if you have one database here and you have some other data over here, it doesn't mean you have to copy some of the data over. A virtual warehouse can see all of your data. So that's a differentiator for us. You can also flex up as you need it. Let's say you need to ingest a whole bunch of files. You can flex up from a small to a medium, and that those resources immediately appear. Then you can run that work, and then you can flex back down again or turn it off if you're not using it. So that's another differentiator. There's not downtime when that happens. It just immediately flex up. Now there's also a separation of duties. So each cluster runs completely independent of each other. So you could have an extra small warehouse that was ingesting data, perhaps for ETL. You might have a data science cluster, maybe it's a medium, 4 machines, and then you could have executive dashboards running maybe on a small. And any one of those can't interfere with any other. In fact, you could be loading data into a table and querying it in one of the other virtual warehouses, and then the global services layer would make sure there was no dirty reads, and all of that just worked correctly. And so the other part of that that's quite valuable is what happens when there's periods of huge amounts of concurrency. And so typically when that happens, let's say there is like on a very busy day where everybody's jumping in. Maybe it's the end of the quarter or during some big event. Well, what happens is that what we can do is normally as soon as all those queries hit that server, it would start to bog down. But with Snowflake, you can set a service level agreement to say, okay, that one's going to be busy, and the first query to queue goes to the next virtual warehouse, and then another one, and another one. So we keep creating clones until that work is done, and we've met that service level agreement, and then you can start backing them down as you don't need them anymore. So that's the architecture. That concurrency is one of the reasons why a lot of people move from some of the other cloud data warehouse platforms to us, because that's something we do very, very well. So basically, it's one platform, one copy of the data for many different types of workloads, essentially unlimited performance and scale. Google and Amazon and Microsoft, they're not running out of storage. It's secure governed access for all the data. And because we deliver it as a service, essentially it's near zero maintenance. So it's not unusual that a company that had a Hadoop cluster that had 10 people maintaining it, making sure it was running and performing, that maybe now they have a half-time person looking after that cluster once it moves to Snowflake. Our customers are people that you've heard of, companies you've heard of. In the energy space, it's people like Devon Energy and Chesapeake, ExxonMobil, Marathon, NOV, Marathon Oil, Encino Energy, who was presenting on one of the other stages, and more. So large and small, it's pay as you go. So pricing can fit in with any size company, can make sense. And we tend to win on simplicity and price. So we've got some webinars linked in our virtual booth you can look at afterwards to see, well, what did Devon do? What did Chesapeake do? And you can watch through some of those webinars that they're there. And just as you know, our customers, we're on your favorite cloud providers. We support a multi-cloud strategy. And we support the BI tools that you know and like. So if you have Spotfire or Tableau or Power BI, those tools have native connectors and connect right into Snowflake. Similarly, your ETL tools, your Informaticas, your Talons, just work, your Alteryxes, as well as the data science tools. And so with that, that's my brief overview. I want to get into a live demo. I actually want to show you Snowflake in action. So hopefully you will see my screen as I'm presenting. I believe you are still seeing my screen. Maybe one of the moderators can speak up if that is not happening. But this is what Snowflake looks like. It's a very, very simple interface. So on down here on the left-hand side are all the databases I can actually see right now. I mentioned data sharing. We actually have a data exchange where you can click and say, here's some freemium data, and then you can also pay providers to download data. But here's how they show up. You don't have to go download that data, copy it into your system. It automatically appears there and it's live. The second the provider updates it, it's live in your instance, and it's the same blocks. We're not copying the data. It's the same blocks in the object store. So we've got some weather data here I've got linked. I also, interesting, for this pandemic, we have a provider that we're sharing data for free, all of the publicly accessible data, and companies were already downloading this themselves in many cases. You can just sign up for it and it'll appear in your instance, whether you're a Snowflake customer or you're just running a trial account. You can get this data and see all the publicly available information updating in real time as it gets updated. So that's been a help for many of our customers. Over 400 customers. It only went live less than a week ago, and there's already 400 customers using that data today. So what I want to show today is how do we work with some of these standards. And so WITSML, for instance, is an open standard that many people are using, and we can ingest semi-structured data just like we ingest structured data. So what I'm doing here is I've kind of cut down what my demo is going to be. We have a whole thing where we stream data in to the system and do all sorts of stuff. But in this case, what I'm going to do is I'm just going to step through the processes that I did to do this demo. And so first thing I did is I created a database called XML tutorial. And you'll see currently there's a bunch of tables there, which I'm going to go ahead and delete. And we're going to start from scratch. The first thing I did is I said I wanted to have a file format that told Snowflake that I wanted to load an XML file. But this could have been a JSON file. That's probably one of the more popular formats. It could be Parquet, Avro, Orc, any of the semi-structured formats. Well, we ingest that data just like we glean statistics about structured data. We also index all the tags in the semi-structured data. So it performs at the exact same speed that it would have had it been a structured file. So in this case, I just said I want to read an XML file. If it had been out in an S3 bucket or a blob storage, I could have linked over to that. But in my case, I just created a stage that Snowflake manages. And then I loaded data from one of the Energistics wells that they had up there. So I could list the files that are there. In this case, I've just loaded one well. So if I list it, I can see that there's a well that came from that WITSML file. There's a well bore, only one of them. And then there's a bunch of logs. There's like 330 logs that are out there. So the first thing I'm going to do is I'm going to delete all the tables of all the data that I've loaded, and I'm going to start from scratch. just to show you how easy this is. So I'm going to blow these tables away. You can see that it's dropped down there. I'm going to refresh here my left-hand side, and you're going to see in this WITSML schema, no tables. So I'm starting from scratch. And so I'm going to start creating some tables. And you notice it's just as simple as creating a table in SQL Server or Oracle. You just say, create table, and then you give it your columns. Now, one different thing about this one is there is a column type called variant. And variant says, I don't really know what the structure is. It's like schema on read from the Hadoop side, meaning I can load in the entire XML file or JSON file or Parquet file. And then Snowflake's going to make statistics about that, but it's just going to load it into one field called variant. And that's very handy for ingestion, not so handy for the BI tools querying it. So we've extended SQL to allow you to query it in an easy way. And then typically what you'll do is you'll create a view on top of that, or in this case, I'm going to create some flattened tables. So I've created this well table. I'm going to create one for well bores, and I'm going to create one for well logs. So in addition to just having the variant field, I'm also storing a few other bits of metadata, the source file name, and so forth. So notice over here, and I really haven't walked through the GUI yet, so I'm just going to click on a few things. Warehouses is where you define the compute. And right now I'm using this demo warehouse, which is set to be extra small. And we size these by t-shirt size, meaning they start with one server all the way up to 128. And I can see this from the simple wizard. If I wanted to create a new one, I could just say this is a PPDM warehouse. And I could say it's going to be 1 credit per hour. So on enterprise level, that's $3 an hour. If you use the whole hour, but we charge you by the second. So if you only used half an hour, you'd only get charged $1.50, all the way up to 4XL if you had a huge workload for 128 servers. But you can do a lot with just an extra small. Then this is where you set the multi-cluster. If you want to have it support huge levels of concurrency, this is where it will automatically scale out to multiple clusters. Auto suspend, we make it very hard for you to waste money. Meaning, if you've ever played around with the cloud and you put in your credit card and you've, then you forgot to shut down a resource, and then 2 days later you come in and you find you have this big credit card bill. Doesn't work that way in Snowflake. You can just say, I want to set my auto suspend for 10 minutes. And if this warehouse isn't doing anything for 10 minutes, then it just automatically turns off. And auto resume means it'll automatically turn on instantly whenever a query comes along or you try to load some data. So very, very easy to configure, and then it sort of start it and forget it. So in this case, all of my warehouses, my warehouse is off, and you look over here on the right where my demo warehouse is not green. That means nothing is happening there. So I'm going to go ahead and query the data before I even load it. So I'm querying the data that's sitting there in this object stage just to kind of get a feel for what does it look like. And you'll notice that my warehouse turned on. So there's a little green light there. So that means I'm now being charged for this extra small warehouse. Now that's what I expected that to look like. And this is what the XML portion of that file looks like for this well header. So that's what I expected. So I'm basically going to copy this data into basically using the select statement to go and read that data. So basically it's just going to, using this extra small, I'm going to write in this data, and sure enough, it loaded one row. And I could then query this table like anything. I could say select star from this table, and sure enough, boom, here's my result. But this is, again, it's not super useful. I still have this variant here that maybe my Tableau or Power BI wouldn't really know much to do with that. So I'm going to do the same thing now with well bore. I'm going to go copy in the well bore information, select star from that, one row because there's only one well bore. But now I've got 330 files that represent the well log. So that's maybe more than what I want to do for my extra small. So I'm just going to go flex up really fast from an extra small to a medium. And you'll notice now it immediately did that, right? I didn't have to wait for that to happen. It just happened. It suddenly grabbed these machines that Snowflake as a service is already running, and it immediately assigned them to me. So now what I can do is I can copy in those 330 files and just go ahead and hit run, and I can watch it chug through those things. So here it is running that. And those actually represent millions of records within the log files, but there's 330 rows are initially going to be created that represent these logs. And then once they are loaded, I can just say select star from this table, and I should see 330 records that represent those logs. So I can see that took 25 seconds, If I'd wanted it to take half the time, I could have gone to a large to flex that up. And if I flex back down at the end of that, it's really a cost neutral decision, which is quite interesting. Talk more about that later if you have any questions about that. So here's my 330 rows of data, of which I'm only displaying 10 right now. And again, I can see that it's just got the XML file there. Also, we've talked a little bit about governance, and in some of the other sessions they talked about governance. We share all the metadata about your instance back to you. So in this case, I'm querying some metadata that we captured about how those files got loaded. So in this case, I can see these files were loaded on 3/31, which is today, and I can see there was a load for well and wellbore, and then I kept looking at that. I would see 330 logs that got loaded. And all I did to get that data to Snowflake was issue a put command, and I just said put star.xml, and it just pushed all the files up. Now, what does this well file looks like? Well, it looks kind of like this. And again, not exactly useful. What I really want out of that as a BI person is I might want the unique key for that well. I want the name and maybe some of these other attributes. And so I could query this XML. I'm not going to go into the details, but if it was JSON, I would use the tag names to go find which field. And in XML, you have to know a little bit about the syntax, about how to go parse this thing out. But in this case, now I've gone and grabbed some of the field names so I can see well and the version of the well. That's all well and good. But we also have a concept, a command called lateral flatten, which we can actually take out some of those additional fields and flatten them down. So that's what I'm going to do for these tables. I'm now going to create a series of flattened tables. This could have also been a view. And I'm going to insert the data in using that lateral flatten command. And then I'm going to query it. And this is more what my BI tools would expect. Here's my well ID, here's my name, time zone, and all those additional attributes. And that's a much more useful view for the BI tools. And so now I'm going to do the same thing for the well bore. Same kind of concept. I'm just going to create the table, then I'm going to insert the rows from a select statement. I could query that data. Boom, where we go. Now here's the logs. Well, there's some more information in those logs files. So I'm going to create a couple versions of this. One, I'm just going to do the well header, the log header flattened version of that. And we're going to see a lot more rows now appear because we're flattening each one of those arrays back into an individual row. So now, so we had, this is the header. So this one is the one that has 330. But now we're going to start looking at the curves. I'm going to go ahead and create a table for that. And I'm going to start populating the curves. And we'll see that was 62,000 rows. And I can query it again, just like regular SQL. And now I can see, okay, that's quite a useful view for querying that table. And now I'm going to look at the underlying data. I know this is going to be 3 million rows. So I'm just going to go ahead and run this on my medium. And it's going to chug through that. And it's basically breaking apart those 330 files. It's expanding out each one of those. And it just finished that. So that took about 8 seconds to run that. And now I don't need my medium anymore. Let's say I now want to flex down back to my extra small because I don't want to pay for the 4 machines. Now I'm just paying for 1. Or if I'm done with my ETL process, I can just say alter warehouse, demo, suspend, boom. I'm going to turn it off, and you see the little light turned off. I'm no longer paying for it. Now let's do a couple of other interesting things, and then we'll stop and take some questions. If I select count star from that table, I immediately get an answer. It says that was 3.2 million rows, but it didn't actually use any compute. Notice my compute didn't start. So if I click on my history tab and I go over here and I hit my refresh here, that select count didn't take any resources because Global Services, it wrote the data into the object store and it already knew how many rows it was. So it didn't actually have to do any work. So it didn't start my compute. Now, if I was going to select star from the actual data, and maybe I'm going to just look at 1,000 of those rows, you'll immediately see that warehouse restart. So it's not like you have to wait 5 minutes for it to start or something. No, it happens immediately. Now, let's do a couple other interesting things. Has anybody ever heard of a case where you're in production, but you think you're in dev and you accidentally drop a table? Well, here's the bulk of my data. Here's the 3 million rows. I'm actually going to mess up and say, you know what? I'm going to drop that table. And in any database, doesn't matter if it's SQL Server or Teradata or Oracle, if you say drop table, that is an instant process. And then if you need it back, you've got to go back to backups and restore it. But Snowflake has a concept called time travel, and it's set for 1 day for all tables, but you can turn it up to 90 days if you prefer. So if I go query this table now, it's not there. It says, hey, this table isn't there. And so that would be a problem. But in Snowflake, you can just say undrop table, and it immediately reappears. Now, here's something else. If I shut down my compute again, and I go and I do this same query, Snowflake knows if the underlying data has not changed in the last 24 hours since somebody did this query. And if I run that, my compute didn't turn on. And if I look back at my history and I say, I can see that select star, notice that there's no warehouse listed there. That's because it didn't use compute. It got that from what we call the query result cache. So it's yet another way to save some money. So, with that, we've taken some WITSML data, which is in sort of this XML format that for some databases is quite difficult to deal with. We've used regular SQL to process it, and we've created an analytics-friendly version that any BI tool can consume now. And with that, I don't know if the moderator can tell me if there's any questions. I can't see any at the view that I have. If there's any questions, I'm happy to answer them now. Also, if you think this is something that looks useful in your environment, we can give you access to a trial license filled with $400 in credit, and you can play with it yourself. But was there any questions?
Thank you, Stephen. I don't think we have any right now, so but thank you so much for your presentation and for being a sponsor.
No worries. Well, thanks for everybody for your attention today. Please swing by our virtual booth and you can ask us questions if you have questions. Thanks to Trudy and PPDM for giving us this opportunity to present today. And everybody have a great rest of your conference.